got this cool bike, and the plan is to make an e-bike. The first step is taking this free wheel sprocket and welding a motor sprocket to it so I can mount it to the motor, and then the motor would be compatible with the bicycle chain, and yeah, and then we build the project. Because this is a prototype, I decided to use this old material that I had. The material is chipboard, which is not the best material, but if the project works out, I might upgrade it to something better. So basically, I used the jigsaw to cut a nice big hole so I can fit this 12-inch wheel. The 12-inch wheel has a front sprocket from a kid's bike. I installed it onto this wheel, and this wheel is actually going to be installed on the rear. So basically, I took these right angle brackets and I'm going to bolt it to the wheel. I'm going to make sure the wheel is nice and centered. Then I'm going to bolt it down to the chipboard. Once it's bolted down, then we can start trying to align the motor itself. So basically, this is a 500-watt motor that operates at 24 volts, which should be plenty of power for this project. So basically, I'm going to take this kid's bike and I'm going to install it onto this chipboard. So I'm trying to create my own version of an e-bike. So basically, I'm going to take more right angle brackets and then I'm going to bolt the right angle brackets onto the chipboard, making sure that the bike itself is centered, and I just have to bolt it down. And once it's bolted down, I just have to do the wiring and take it for a test drive. But for this test drive, I'm thinking I'm just going to run it on 12 volts. You know, an electric bike has to have the ability to cycle. Otherwise, it's basically just a scooter. But basically as well, it's a scooter with the body of a bike. Anyway, so basically, this beautiful bike gave me the idea to create an electric bike, right? So I thought to myself, because of the small body, if I wanted to fit a motor on this body, it would be very, very hard. Not only that, but because of the motor size, it would be super, super heavy and unbalanced. All right, so come closer. Let me show you the beautiful engineering. So basically, what I thought was, because I already built a scooter before, I thought instead of having the front end of a scooter, why not have the front end of a bike? So I added a bike. And yes, by adding a bike, now there's 3 wheels, right? But there's a problem. Basically, because there's 3 wheels, it doesn't really want to turn properly. Basically, if you turn, the rear wheel at the back would drag on the ground. Like it would start sliding like you're drifting in a corner. It's not that bad, but I think maybe in the future I need to like either put a swivel mechanism so the back half can go left to right, or I remove this wheel. But then if I remove the wheel, then it's not going to be an electric bike. It's just going to be a scooter. All right. So, but anyway, that's a future problem. All right. So right now it's running on a 12-volt battery. It's hot wired. So basically the power from the battery goes directly to the motor through the switch right here. This is a 15 amp switch, right? Once I hit the switch, the motor engages. But here's the thing as well. It freewheels. You see this? It means that when you're pedaling, the motor is not applying resistance to the rear wheel. So basically, it's almost like you're pedaling a normal bike. Now, you may be asking, okay, why did you use a kid's bike? Let me tell you, I wanted something small. Yes, I could have just used a normal bike, but I thought this bike looked awesome. Like it had this vintage style. Now, basically on the bike itself, what I did was the handlebars used to be facing backwards. I thought it would be way cooler to face them forward, like the race bikes, how they have those handles, right? Not only that, but by putting the handlebars forward, it gives me more space. I upgraded the seat, right? And other than that, those are the only two things I touched. And then I added the chipboard, the battery, the rear wheel from a scooter. I added a front sprocket from a kid's bike, and then I added a rear sprocket from a normal bicycle. So the front sprocket can freewheel, and no, the back sprocket can freewheel, and the front sprocket can also freewheel. Pretty cool. All right, so let's jump on this bike and I show you the performance. So as you can see, I've put a phone mount right here, so it would be able to tell me the speed. So basically, just like that, I'll be able to read the speed. All right, so once I hit the switch, the motor will engage immediately, okay? All right, let's do this. I think that should be good. Okay, let's start. So, pedal. Let's try pedal by itself. All right, so this is what it looks like if I try to turn. It turns, which is a good thing, even though it has an extra wheel at the back, right? It's a bit hard in the corners. That's the only disadvantage. But at least I can pedal it. Now here's the fun part. Watch this. Look. Come on. All right, cycling. That's 6 kilometers an hour on the cycle. Make a U-turn, and then we hit the power. That's about 10 kilometers an hour. Ha ha ha. And we are back. All right, so basically I had a problem. The chain, I don't know, for some reason it kept on jumping. So I thought to myself, okay, I made a mistake. Let's improve on that mistake. So instead of putting the motor at the bottom, I put it back on the top. I reinforced the material and I made sure all my measurements were spot on, just to reduce the chances of the chain jumping. All right, come see. Look at that. Look how beautiful it is now. There's the motor on the top now. And yeah, looking good. All right, so now let's test it out. The full potential. Kilometers an hour, 16. $16. 18. 19. Thanks for watching. Please consider liking or subscribing. I hope to see you in another video.